this video on graphing quadratic equations in standard form. By the end of this video, you should be able to graph a quadratic function from a standard form equation, and you should be able to identify the key characteristics of a quadratic graph of the axis of symmetry, the vertex, domain, range, and the intercepts. So let's take a look. So make sure you have your graphing calculator available with you, and if you don't, a phone that you can access a graphing calculator or Desmos. Either of those will work. There's going to be a lot going on, so there's a lot to pay attention to. So let's go. Our first graph is y equals x squared. So very similar to what we did yesterday. We're going to look. The a value is positive, so we know it's going to open up, but now we have a coordinate plane. So we do want to have our graph be the exact numbers that we want. So we're going to go into our calculator. Okay. Go into y equals, if anything's there, please clear it out, and all we have is x squared. So we'll press x and square it. Okay. So let's see. Before we go too far with that, let us find some numbers so we kind of know where we want to start looking. So to find our axis of symmetry, remember it's negative b divided by 2a. There is no b value, so that means the b is 0 divided by 2 and a is 1. 0 divided by 2 is just 0. That gives us the center of the graph. It just makes it easier if we know where the center is before we start. So that's our axis of symmetry. So what I like to do, x is 0 is this line right here. So I'm just going to draw in my axis of symmetry so I know my graph is going to be symmetrical about that. X equals 0 is the name of that line. I know my vertex has the same x value. So now I've got my equation in. Go look at the table of values, which is second graph. And we want to go to where x is 0 and my y value there is also 0. So now I know my vertex is at 0, 0, which for the graph is right there. Let's get some other points to graph. And so this is where the table of values is really very, very handy here. Let's see if we can get that so we can kind of see it a little bit better. Okay, so we have negative 1, 1. So I'm going to go negative 1, 1, negative 2, 4. So I go to negative 2 and up 1, 2, 3, 4. I'm going to look at negative 3 goes up to 9. So I'm going to go negative 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I only did half of this because I want to show you something. Because the axis of symmetry is the very center of the graph and it's symmetrical, if I were to fold this graph in half, the points would line up on the other side with the other point. So if we look, do you see how this point is 1 away from the axis of symmetry? 1 to the left, so I'm going to go 1 to the right from that same level, and that's where that other point will be, and we'll just take a look. If x is 1, my y is positive 1. So that's 1, positive 1. Let's go here. This point is 2 to the left of the axis of symmetry on the same level. I'm just going to go 2 to the right. So that's where x is 2, x is 2, y is 4, and look, 2, 4. So it's just a quick way to kind of get the rest of the graph on. This point is 1, 2, 3 from the axis of symmetry, so 1, 2, 3 on the same level. And there's the matching point. It's symmetrical. So we want to graph this in. Remember to curve the bottom. It's not a point. Okay, do the best you can. So then here we have our quadratic. This is actually what we call the parent function. All of the other quadratic equations are born from this one. See, and it has the most simple thing here. It has nothing else going on with it. It's just x squared. Now our domain. In non-real world problems, we're putting arrows on the end. This is saying it's never going to stop going left and it's never going to stop going right, and that makes our domain all real numbers. For our range, just like yesterday, it's all built is the graph all above the vertex or is it all below the vertex? So our y values are all, the vertex is at the bottom, so all the y values are higher than it, greater than, and it's all greater than where y is 0. So that's our range. And this graph will have a minimum because it opens up. Okay, so this is the same as what we did yesterday, but now we want to put it on an actual graph so we can take a look at it. All right, I'm going to make it a little more complicated here, and so I'm going to mix in some of these word problems for us. So now we have a soccer ball. It's kicked from the ground with an initial upward velocity of 90 feet per second. The equation h equals -16t squared plus 90t gives us the height of the ball after t seconds. So the h stands for height, and that's really your y-axis. And our t is our seconds, and that's our x-axis. Okay, but we're going to treat it just like we did up here. So we can find the axis of symmetry. It might not be pretty because this is a real world problem. So we're going to look, here's our equation. Negative b, so b is 90, so negative 90 divided by 2 times a, which is -16. So I get negative 90 divided by -32. And this is real world, so we're going to take some decimals here. So I have negative 90 divided by -32. And I got let's round it to 2.81. Okay, so that's where our axis of symmetry is at 2.81. That's not a nice whole number, but it's somewhere between 2 and 3. So I'm just going to draw my axis of symmetry between 2 and 3, because I know that's where my graph is going to center itself now. X equals 2.81. Okay, I'm actually going to move that off to the side because I'm going to want to write a vertex, and I know that it's up there. So x equals 2.81. Give myself some room. Now, is 2.81 in our table of values? No, it's not, but let's go ahead and put this in. Go into y equals, clear out anything that's there. And we have -16. They use the letter t, but we only have x, so just put an x squared plus 90x. And when we look at the table of values, we do not have 2.81 in there. We have all whole numbers. So here's what happens. You're just going to plug in 2.81 into this equation. So it's -16. The x value we got is 2.81 squared. So that's what this says right there. Those say the same thing. Plus 90 times that value. Plus 90 times 2.81. And that's going to equal, well, I don't know, but we're going to put it in just like this. So exit out of here. -16 parenthesis 2.81, close your parenthesis, squared, plus 90 parenthesis 2.81. It's just like it's written, and you press enter and you get 126 let's put 56. 126.56. That's the y value of the vertex. Okay, so we did the x, which is 2.81. That's our axis of symmetry. Our vertex has the same x value, and our y value is what we just calculated right here of 126.56. They're not pretty numbers, but it's okay. So somewhere way up here, we're just going to fake it. This is 2.81, 126.56. That's the name of the vertex right there. Okay, now think about it. They said they're going to kick it from the ground, and it's going to go up, and it's going to come down. So it's going to open down, which is going to give us a maximum. Our vertex is going to be on the top. Okay, so let's go get some values. We're going to make it easier on ourselves, and we're going to just take some positive, the whole values that we can get. So we have our equation in. Go look at your table of values. Now look at that, -1, -106. I can't get there. I can't graph that, but I can graph 0, 0. So I'm going to graph 0, 0. I'm going to look where x is 1, and that's 74. That doesn't really help me. 2, 3, 4, 5. But look right here. What happens between 5 and 6? I go from a positive y to a negative y. So somewhere between 5 and 6, I cross over the x-axis. 1, 2, 3, 4, 5, 6. So I'm just going to kind of give myself this little spot for right now. So we're going to fake graph it up to the vertex and down. Now, why did I stop like that? I didn't go past the x-axis. I didn't continue it. I didn't put arrows on it. And that's because in the real world, we only exist in the first quadrant. So I'm just going to kind of cross off the rest of this because we're not going to use it. We're only going to look what happens in this first quadrant. All right, so for our domain, I would need to know both of these numbers. I don't currently, and we're going to come back to answer our domain question. For my range, the graph exists. The ball started at the ground and it went all the way up to here and then it came back down. So the ground for a y value is 0. Okay, so we got to do our full interval notation. We talked about this previously. So 0 is less than or equal to the y value because we're talking about y values. But it doesn't go up forever. It doesn't go past the y value of the vertex because that's the very highest point. So that's going to be no more than 126.56. Okay, so the ball started here, it went up to 126.5 feet in the air, and then it came back down. So your range is from the ground to 126.56 feet in the air. All right, we're going to come back and answer the domain question in a few minutes. So find the maximum height of the ball. Well, look, we said it's a maximum. What was the maximum height? Well, the height is this way. That's our y value. So it went 126.56 feet into the air. Okay. And then when did the ball hit the ground? So it started here and it went up and it hit the ground right there. I need to know the name of that intercept and we'll come back to that and do that in just a minute. So let's try just a regular old graph again. They're a little easier to look at. But it's important to understand how this works in the real world. So to find our axis of symmetry, we do -b divided by 2a. So b is -8, so I have +8 divided by 2 times -1. So 8 divided by -2, which is -4. That gives me my axis of symmetry. I like to draw it in, so I'm going to go 1, 2, 3, 4 and draw him in because I know my graph is going to center on this line. X equals -4. That also tells me because the axis of symmetry goes through the vertex, they share the same x value. So to get the y value, we could plug it in like we did up here, or because this is a nice pretty whole number, we can go in and we can look in our calculator. So go into y equals, clear out anything that's in there, and I have -x² minus 8x minus 17. Okay, look at our table of values. And we have an x value of -4. So when I look, I see that my y value is -1. So we'll look at this one. It's a little bit easier to see. So we had x value of -4. Our y value is -1. And always look below and above to make sure that you see that symmetrical pattern coming out so you know you're in the right spot. So I have my y value of -1 for my vertex. Okay, so -1. So we can go ahead and graph it. -4, -1. We'll label it -4, -1. And we're going to get the rest of the points now. Okay, so we have -5, -2. And remember, I talked about the symmetrical. This is 1 away from the axis of symmetry to the left, so I'll go 1 to the right on the same level. Then I have, let's see, -6, -5. There's -4, 5, 6, -1, 2, 3, 4, 5. It's 2 to the left, so I can go 2 to the right on the same level. And then I have -7, -10, which is all the way down here. That is 1, 2, 3 to the left of the axis of symmetry. So I'm going to go 1, 2, 3 to the right to put the other corresponding points so they're symmetrical. I'm going to draw my curve. This is not a real world problem, so I'm going to put arrows on the end. Okay, so let's take a look at this. For our domain, it's never ending left to right. So that is all real numbers. For my range, that's talking about y values. The entire graph is below the vertex. So all of my y values are less than or equal to the y value of the vertex, which is -1 because they don't go above that. And I have a maximum here because the vertex is on the top of the graph. Okay, so hopefully we're starting to kind of feel this a little bit. At least for these plain ones, the word problem ones might take a little bit more. So we're going to try a couple more of those and see how we do. So we've talked key characteristics of the vertex and the axis of symmetry and whether there's a maximum or a minimum and the domain and range. And I want to add in there the intercepts. The X-intercepts, we also could call them roots, solutions, or zeros. And that's where the graph crosses or touches the x-axis. We can get it by solving by factoring. We could use the quadratic formula. We can look at a graph and we could look at a table of values and look where y equals 0. Okay, that's for our x-intercepts. Our y-intercept is where the graph crosses the y-axis. It is the c value when your equation is in standard form. So whenever you look at your standard form equation, the number at the very end, the constant, that's your y-intercept right there. So this one's going to start off at 25. Okay, so you can find your y-intercept by looking at the c values in standard form. You could look at the graph, or you can look at the table of values where x equals 0, and that's going to tell you what the y-intercept is. So let's keep trying some of these, and we're going to add some intercepts in. Okay, so in science class, students were asked to create a container to hold an egg. They would then drop this container from a window that is 25 feet above the ground. If the equation of the container's pathway can be modeled by this equation, h equals -16t squared plus 25, how long will it take for the container to reach the ground? Okay, so it's saying, so we're not really throwing something up and having it come back down like we did the ball on the other side. This is they're starting up high and they're dropping it. So you're really only seeing one part of the quadratic equation. But let's go ahead and figure out what we've got. Let's get our axis of symmetry so we know where we're starting. X equals -b divided by 2a. And there is no b value. There's a is -16 and c is 25. So our b value is 0 divided by 2 times -16. So our axis of symmetry is at x equals 0. Okay, so I'm going to graph this in. There's my axis of symmetry. I like to see it so I kind of know what I've got going on. So this is x equals 0. Now, this is a real world problem, so let's kind of look at this. Let's find our vertex. So go into y equals, and let's put our equation. Clear anything out that's in there. -16, we don't have t, just use x squared, plus 25. And we're going to go look at our table of values. When x is 0, y is 25. So when x is 0, y is 25. Oh look, that's when x is 0. Didn't I say where x is 0 is what our y-intercept is? That's our y-intercept. Didn't I say the c value is the y-intercept? There's your c value at 25. Now our graph doesn't go up to 25, so we're going to just kind of fake it right now. We're going to say that's 0, 25 for our vertex. So let's look. -1, 9. And I'm going to use symmetry to get this point over here. We could look at +1 also. +1, 9. Positive 2 is -39. Well, we're not going to go to -39. So somewhere between -1 and -2, the graph is going to go below 0. So let's look. If we do -2, we get -39, but we're not going to go below 0. So somewhere between -1 and -2, it goes below 0. So our graph is kind of tall and skinny. And it would be a lot taller if we went all the way up to 25. So it kind of looks like that. But what I want you to do is I want you to cross off all of these other quadrants except for the first quadrant, because we're not going to talk about anything in them. We're only going to talk about what we see in the first quadrant. So I'm going to just even cover this up right there to help us see it just a little bit better. That is the only part that we're talking about, this piece. So from where they were on the ladder at 25 feet, and they dropped their egg until it hit the ground. Okay? So our domain is our x values. So we'd only be talking from here to here. I need to know what that intercept is. Our range is from the ground to our very highest point. Well, we never went taller than 25. That was where we started at. So we can do range right now. From the ground is less than or equal to the y values. And all of those y values are less than or equal to 25. Because we're going from the ground at 0 to a height of 25. Okay, and that's what this says right here. Our y-intercept, where does the graph cross the y-axis, is where x is 0, so 0, 25. Our x-intercept is where the graph hits the ground, is really what we're looking for. And these are not pretty whole numbers. They happen between numbers. We're going to have to do quadratic formula to get those numbers. Well, let's answer some of these other things first. There's one other thing that we can answer right away, and that is, do we have a maximum or a minimum? Well, we're opening down, so we have a maximum. So now what we're going to do is we're going to need to do a quadratic formula to find these x values to help us with our domain. Okay, so we're a little light on room here, so I'm going to do this so we can write it big enough. So I'm going to use my equation, -b, well there is no b, so 0 plus or minus the square root of b squared minus 4 times a times c, and the whole thing is going to be divided by 2a. Okay, so I used my equation. I plugged everything in just like we did before. Okay, as we begin to simplify, remember how I said we can just cover the 0. So really I have plus or minus, and I want to know what this number is. What is that number underneath the radical? And it's going to be divided by -32, because that's the 2 times -16. So I'm going to say 0 squared minus 4 times a times c, and that gives me 1600. In the real world, we want to get the numbers. I happen to know that that's a perfect square, but it doesn't matter. We're just going to take the square root of 1600 and it is 40. So plus or minus 40 divided by 32. These are like terms. We can combine them. So what this is saying is we have positive 40 divided by negative 32, and we have negative 40 divided by negative 32. So we're just going to calculate those out. Divide 40 divided by negative 32 is negative 1.25. And negative 40 divided by negative 32 is positive 1.25. So what it's saying is we did this whole quadratic formula. I'll move it down a little bit so we can see. I have a negative 1.25 and a positive 0.125. So this is on the positive side because it's a positive x. This 0 is called 1.25 comma 0. That's the name of the point where this crosses the x-axis. And where this graph side crosses the x-axis is at negative 1.25, 0. But we're talking in the real world. Okay, so in the real world, when I start talking my domain, I need to start at the real world spot. So the x value there is 0. So from 0 to 1.25, that's the whole domain. This little section right there, that's the domain of this graph. So it starts at 0. We're talking about x values. So 0 is going to be less than or equal to, and we don't go past the egg is going to hit the ground at 1.25. So that x is going to be less than or equal to 1.25. Okay, so this is the whole domain from the origin to right there. Now for our X-Intercept, we have two. Only one of them happened in the real world. We'll go ahead and list both of them right now. Negative 1.25, 0. And 1.25, 0. So the question is, how long will it take for the container to reach the ground? So the question had said, this is time, and this is height. So you're all the way up here at 25 feet, and you drop it, and it hits the ground right there. How long did that take? That took 1.25 seconds, because it said our time was in seconds. Okay, so where it hit the ground, our x value, our x-axis here is time, so that's how long it took, 1.25 seconds. Hopefully you're kind of feeling how the real world is relating to our graphs. They're a little bit more complex, but we'll get used to them as we keep practicing. Let's finish this out with just two regular graphs. This should be a little bit easier. So let's get our axis of symmetry so we know where to start. And so we're going to have x equals negative b divided by 2a, which is 3 divided by 2 times 1. So I got a positive 1.5. We have an axis of symmetry that's not on a whole number, but that's okay. 1.5. So I'm going to go draw it in over here. I'm going to go halfway between 1 and 2. And I'm going to draw it right there. And we have x equals 1.5. That is also the x value of our vertex, so we know this. It's 1.5 something. So what we're going to do is we're going to plug it into our equation. It says x squared minus 3x minus 10. And our x is 1.5. What is that number going to equal? So once you've got it set up, you can just put it into your calculator. Parenthesis 1.5, close it, square. Minus 3 times 1.5 minus 10. So it looks just like it. I wrote it down. I write equals, and I get negative 12.25. Negative 12.25. So my y value is negative 12.25. So that's my vertex. It is down here. It's off the bottom of the chart, so I'm just going to make some room for it here. And we're going to say it's at positive 1.5, negative 12.25. Okay, so we're going to go back into our y equals, clear out what's in there. X squared minus 3x minus 10. Go look at our table of values and just get some numbers. So I've got negative 3, positive 8. So negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And it is 1, 2, 3, 4 in a little bit. So 1, 2, 3, 4. So we're symmetrical. Negative 2, 0. Oh, I like to hear that. That's an X-intercept right there. Look at that. I'm not even going to write it. X-intercept, negative 2, 0. It's a nice, pretty whole number. We've got it. Okay, and it is 1, 2, 3. So I'm going to go 1, 2, 3 on the other side. So that is 1, 2, 3, 4, 5, 0. And if we weren't sure, we could keep looking. When I get up over here, 5, 0, it says the same thing. Okay, 4, negative 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That is 2 and a smidge. So there's 1, 2. Okay, so we're getting closer, and then 1, negative 12. So that is like just a little bit. So we got a whole bunch of points here to help us draw this big guy. All right, so we get this big graph because we're able to see. We started at the bottom, we were able to go all the way to the top. We could have kept going if we had a bigger graph because this is never stopping left or right. So our domain is all real numbers. And our range, our vertex is here, and the whole graph is above the vertex. So our y values are going to be greater than negative 12.25. And our y-intercept is where x is 0. We didn't actually graph that one, but we can look right here where x is 0, y is negative 10. And if we look right there, negative 10. So our y-intercept is at 0, negative 10. And this graph, that vertex is on the bottom, so it's a minimum. All right, one last one. I want you to try as much as you can get done, and then I'll talk us all the way through it. All right, let's see if you were able to get started. I started by finding my axis of symmetry, and I got x equals 0, which is right here, your y-axis. And when I looked at I put my equation in where x is 0, y is negative 2. So that was my vertex, so I plotted that. And then I just went and got points off the graphs because you don't want to go far away. We just picked the points right around it. And I graphed all the points and connect them together. So now let's try and answer some of these questions. For our domain, it's easy when we're not talking real world problems because they're not stopping left or right. So it's going to be all real numbers. Our range, what y values are included in this graph. The vertex is here. The entire graph is under the vertex, so that means y is less than or equal to. And it'll be whatever the y value of the vertex is because that's the highest point. It's not going to go past that point. Our x-intercept, this graph never comes to the x-axis, so we're going to write none. Don't leave it blank. You got to write something in there. Our y-intercept was right there at negative 2, and if you look at our c value in our equation is negative 2. So we'll say 0, negative 2, that's the name of the point. And this guy is a maximum. All right, that was a lot. Hopefully you were able to get it down. Go back and watch the video again if you need to. Let me know if you have any questions. See you in class.